Now finally, let's have a look into accessing the email. Because I told you, transfer is one thing, but what happens if the receiver is not online? We need something else. So important that email recipients, we're not always online. So in the morning we switch on the computer, we have a look at the mobile phone, whatever, and check the email. Okay, so typically we don't have at the same time don't have a direct access to inboxes. So for example, inbox could be stored in a file system. Now you don't want users directly accessing file systems, so we need a special tool, protocols. So remember our architecture. So we send our email from the sender. This is where we have our SMTP, but SMTP sets up a TCP connection. We have SMTP here in between, setting up our TCP connection, SMTP, but then we have the mail stored here. And here we access it, and there we have classical and a bit newer protocols, a certain choice. So the very classical one, POP3, Post Office Protocol version 3, very simple. Most of the tools, they still know this, deprecated a bit. So why? The point is the original basic version, well, you have a login password without any encryption. So just listen to the communication and you know all these things. It's very simple. You can log in, log out. You can copy emails to you're downloading emails to your local computer. You could delete emails from the server. And that's it. So you have certain authorization phase, but that's all clear text username. You have a transaction, simple commands. You could delete messages, retrieve, do a listing, etc. So very simple thing. As you see here on the right hand side, you set up your connection setup phase, and then you send your commands and you get your replies. Very simple. First example for this. Authorization, I'm this user, great, this is my passport, hey, clear text, great idea, you're successfully logged in. So this is why there are some providers, email providers, that do not allow using POP3 without encryption or do not allow it at all. And then transaction, you can send commands like listing, oh, there's a list of messages, so message 1, with a certain number and a certain size, etc. Then you say, okay, retrieve message 1, and then you will get it or you can delete it. So that's very simple. So that's the core idea, but it's very limited, and the main problem is you cannot have multiple clients. What happens, if you have several clients and you download the email to one of the clients, it's gone. It's gone from the server. But that was the old days. So pretty soon there was a new protocol coming up called IMAP. This is something maybe most of you know, that solves issues with we have no encryption, or we have no folders, we cannot sort the mails, and we cannot use more than one host, etc. So we solve the problems of POP, and many clients implement both, but IMAP is the preferred one. And there's also the RFC 3501. That is typically most mail solutions do this. So IMAP can do many things, still less than, for example, proprietary clients for an Exchange server. So IMAP is not for synchronization of calendars and contacts and these things. So using then, for example, Outlook and Exchange, you can do more. The same is true for web mailers. You can do more. So how does it work? IMAP in a bit more detail. Also there you have a default port 143. All the emails remain on the server, but may be cached. So you can work offline. So that's a good idea. So the server does all this searching, changing, deleting stuff. That's good. And you can also have different hosts. So if you're a nomadic user, if you have multiple clients, if you move from A to B and you just check the email, this is what you want to have. It's more complex, yes, that's clear, but you can do more things. So that's basically all about IMAP. And we can also use webmailers. That is also possible. So webmailers, basically you use a browser and you interact with your mail server using a browser. So that's the idea. And then the connection between your browser and the web server / the mail server can be protected. You use HTTPS. We'll come back to HTTP in the next sub-chapter. And there are many quite popular implementations like Gmail with these 1.5 billion active users. Actually, webmail exists since 1993. There was one of the first webmail implementations at CERN. You know, CERN, where the web comes from. So, okay, so that's the idea. But this brings us to another issue I already mentioned. So now, okay, we use HTTP for accessing email because it's so convenient to use the browser. And this brought up yet another discussion that more and more things, you know, already our hourglass model, where I say we have this narrow waist of IP, and we discussed the advantages and the disadvantages of the narrow waist. And now, it's so convenient to have HTTP, this more transaction-oriented protocol. It's reliable, and this is the nice part, is, why not using HTTP? Because then we can penetrate firewalls. Oh, isn't that cool? So if we run applications and protocols, web services on top of HTTP, why not then doing everything via this HTTP? Because we know with HTTP we can penetrate firewalls, it easily goes through, and we have yet another slim waist up here. There's even IP, don't laugh, via HTTP, via UDP, via IP, etc. Things like this, because we can. So proxies, firewalls, etc. may block other protocols, but quite often HTTP you let through, and this raised some issues. Okay, we will come back to this when we discuss HTTP and some other protocols, if this is a good idea or not. Now finally, let's go through an email header. Why? Because this shows you a lot how it works. So we have the envelope to transport outside, and now we are inside, we're looking at the header. So switch on, it depends on the client, a look into the headers. So most of the clients allow this, show the internet headers. And then you will see something that looks like this. Ooh, confusing. Well, to follow the trail of an email, you have to read this from bottom to top. Or if you read from top to bottom, you see, this was the latest computer receiving the mail. So you see the computer Spree, river in Berlin, whatever, received this with a certain SMTP service, etc. That's not the point. But you see, and this is why it's good for debugging, you see the time, you see the date, and you see this is the MTA used by the email recipient. So reading from top to bottom, that means, okay, that's the newest entry here, the newest one. And the newest one is the closest one to your user agent where you read the mail. Before that, now we go back in time. Before that, we see this mail was received by Qmail, received by Qmail, received, and so on. And you see many more computers involved, and you see strange loops. For example, spam and virus filters running on certain computers. So what you do sometimes is you hold back mails for different receivers, and then you perform kind of a cross-check. And if it's the case that many different receivers get the same mail or a mail from the same sender within a certain time limit, this pretty much looks like spam, kind of a spam attack or whatever, trying to send something to many of your receivers. Unless this is kind of an authorized sending to many receivers. So this is why it's a good idea to say, okay, now I want to send an email to all the students of the university. So otherwise they will end up in our spam filters. Okay, so you go back in time and you see there are many message transfer agents here at our university, and then, oh, this is the origin of the mail is here at Humboldt University. Another university here in Berlin, you see again the computer. So you see it went from Humboldt University to Freie Universität, and then if you continue, you go back in time and you see, okay, where all this comes from. And now you see, okay, these were all our MTAs, and that's the last one, that's the source email server. So that was the first MTA where the user agent contacted this one. Then we have some more information here in the header. This is now special stuff. Always see these X. These are extensions for special purpose, could be also proprietary purposes. For example, a virus scanner that checked something, etc. Then you see MIME, multipurpose internet mail extensions. What does it mean? Here you see, okay, the content here is a multi-part content alternative. That means, okay, we have the same message with alternative representations. For example, could be plain text and HTML, something like this. And we have now this separation. It's not in original mail in red, it's just for you to notice this. So this is some kind of a random looking string that indicates the border. A border, a boundary between the different parts. And then we have parts that are displayed at the user agent, Happy New Year, in German here. And what was the client producing the mail, and what was the date and time, certain message ID, also long number. We need this. Why? If you have a thread view for your emails, for example, you have to know, okay, all these emails belong together. So in reply to that, you know, okay, this is reply, so this belongs to this and that. Okay, thread topics and all this stuff. So this is identification of the message, and then so you know, okay, to sort in, oh, is it a new one, and all this. Thread index to know, okay, this is the thread where it belongs to, etc., etc., etc. Then we have our to's and froms. You see, gray listing, and it tells you, oh, it was not delayed in this case. Status, virus status, etc., etc. And then it will tell you, okay, there are two parts that will follow. And one is a plain text. So it says plain text, and one is HTML. So we see plain text, and we see an HTML part that will follow, and we see these basically the borders. You see these string that we defined to separate this. And then a substructure starts, and in this case, the substructure, now it's just parts of emails, just giving you examples where you can also define boundaries for separating pictures, just to show you how a picture is coded, etc. And this is then our JPEG, and for the other examples we had text and HTML. So these are just examples. So cool, emails can now have many different types of contents, multimedia, etc. Drawbacks, it's way more complex, so it's not this command line stuff where you can simply debug. So it's now a bit more complex, but it still works. Plus, this increases the size of an email. So if you have a JPEG of, let's say, 3 megabyte, if you encode it base 64, you will have 4 megabytes roughly. So you will get an increase of about 30% by this base 64 encoding. Okay, you have to take this into account because sometimes you have upper limits, so maximum limit of 10 megabyte per email. But if it's a picture, this will result in whatever, 13 megabyte, it will not go through. So this gives you a little bit of an insight. Please do this on your own. Check this, check the headers, learn a bit more so that you at least have certain impression of what's going on there. If you want to read more, there are for sure all the RFCs for message contents, text, MIME, so many RFCs, but also RFCs for the transportation, for SMTP, for IMAP, so different RFCs and their updates. And many, many, many more for security frameworks. So, coming back to one of the very first questions. So, what is this with email? Still used? Yes, no? Well, this is an older article, 2005, long time ago, so almost 20 years. Just giving you an impression, also already at those days, many people relied on email, and still today, people rely on email. It's important to remember, email is not a guaranteed service. It has non-trivial loss rates. We have latency, sometimes latencies longer than days. We have sometimes strange errors, but surprisingly enough, it works for 99% of the time. So typically, email is considered as reliable, but you cannot be sure. It's different inside a company network with a whatever, for example, Exchange server network, then you can give some more guarantees, but the internet email, well, it depends. Typically, it works. Some final questions. So, we saw, okay, we have some special protocols for accessing emails. Writing, we use a user agent, accessing POP or better IMAP. So, but you can also use HTTP. What are pros and cons for using HTTP for so many different things? And, well, are there still reasons remaining? Why should I use IMAP at all? I mean, I have a webmailer, so why using IMAP? Webmailer, I can do everything with a webmailer, or can I? So, please go into your email, whatever email system you use, take an update email, check the headers. What are the typical components you will always find? Maybe you find some surprising content there. So it's quite important for you at least to understand, to follow the way, to read these headers. Then you see, okay, this is the way how it works.